Hi everybody, this is Dr. T. Anthony Santosh, Assistant Professor of Chemistry, St.Joseph's College of Arts and Science, Cuddalore. I am handling physical chemistry, and in this video I would like to discuss some of the topics present in the paper of PG course Reaction Kinetics, Electrode Kinetics and Photochemistry. Let us see the introduction of photochemistry and the importance present in it. Photochemistry is a branch of the chemistry subject concerned with the chemical effects of light. We can explain this photochemistry in different manner, and the photochemistry is like chemical reactions, and it is, as given in the first point, it is the consequences of light radiation or irradiation of light. Generally, this term is used to describe a chemical reaction caused by absorption of ultraviolet and visible radiation. Usually, this will be in between 200 nanometer to 800 nanometer. So, in between, mainly this is caused by the reactions between ultraviolet radiation and visible radiation, and sometimes the infrared radiation also involved. And actually the energy involved in the photochemical reactions are in between 36 kilocalories per mole to 143 kilocalories per mole of energy. The related photons should be of sufficient energy to raise the atoms or molecules from the ground electronic state to an excited electronic state, which is essential qualification for the carrying out of photochemical reaction. This involves the promotion of an electron from a bonding molecular orbital to an anti-bonding molecular orbital. This is the first required step, the excitation of an electron from a bonding molecular orbital to anti-bonding molecular orbital. Next, I would like to explain you the thermal reactions and photochemical reactions. So thermal reactions are normal chemical reactions. Okay. So how it differs with photochemical reactions, or how it varies with photochemical reactions, that now I would like to explain you. So as you are seeing now, it will be better if I explain you with as a comparison of different points of the table. So in the first point of thermal reaction, so every reaction needs energy, and we used to study from our school level the energy is related to spontaneous reactions, and here is the main point of Gibbs free energy. The thermal reactions proceeds with the decrease in Gibbs free energy, that is delta G is negative, that we know already. But what about photochemical reactions? It proceeds with an increase in Gibbs free energy, that is delta G is positive, which is a surprising factor. And in the case of thermal reaction, we are carrying out at normal condition in our laboratory without any special equipments, or sometimes we are using special equipments, but it is easy to carry out. The thermal reactions are easy to carry out. But at the same time, the photochemical reactions are very difficult to carry out. Very difficult to carry out. Okay. Next, the third point is the thermal reactions are carried out or taking place by changing vibrational levels within the ground state electronic level. Okay, we could see that different levels of energy, vibrational level, electronic level, translational level, like that. So in the case of thermal reactions, thermal reactions are taking place by changing vibrational levels within the ground state electronic level. Therefore, thermal reactions are higher vibrational reaction of ground state electronic level. Clear. But in the case of photochemical reactions, the photochemical reactions take place by changing electronic levels, higher electronic level reactions. We can understand that these photochemical reactions are higher electronic level reactions. Next point we could see in the thermal reaction. In general, the thermal reactions proceeds with the charged intermediates. As we are knowing about what are all the charged intermediates, cations, anions. So these are the charged intermediates. When we are looking at the reaction or different steps involved in a reaction, we will see that there are charged intermediate. First, the charged intermediates are formed, and the charged intermediates are transforming into giving the final products. This happens in the case of thermal reactions. But in the case of photochemical reactions, the reactions proceeds with free radical intermediates, which are higher in energy and which propagates the reaction to higher levels. It proceeds, that means the photochemical reactions proceeds with free radical intermediates. Next, the fifth point is polar solvents are used in thermal reaction. And for thermal reaction, polar solvents are very much suitable. Why it is suitable? We are not supplying much energy to the reactions, to the reactants in many cases. We are using temperature, of course, but when we use polar solvent, the polar solvents are charged. They are suitable for the reaction, so charged. So they are enhancing the reactions. So polar solvents are suitable for thermal reactions. But in the case of photochemical reactions, the non-polar solvents are suitable because the intermediates itself are free radical intermediates. They are higher in energy. If the solvents themselves become polar, means that will not be giving us the desired product. That may lead to some other reactions. So non-polar solvents are suitable for photochemical reactions. The sixth point in thermal reactions is increase in energy is non-specific. Okay. And when you are looking at the photochemical reactions, the increase in energy is specific because we can do the energy of some molecules or part of the molecule can be increased by irradiation. For every photochemical reaction, radiation is a must. So using the radiation or shining light is the simplest thing of radiating the reactants. If we do that, we can get the desired products. Okay. And in this, at the seventh point of thermal reaction, it is difficult to synthesize. Thermal reactions are difficult to carry out, and it is difficult to synthesize strained products. Strained products are much difficult to synthesize in the thermal reaction. In the case of photochemical reactions, we can synthesize strained molecules, so that it gives some advantages for getting the strained molecule preparation. Okay. Let us see what are all the photochemistry laws. Every concept, every different chemistry is related with certain rules and regulation. Every classification of a particular topic or everything leads with it certain rules, that is called laws. So likewise, this photochemistry, the branch of chemistry, one of the branches of chemistry, is also related with certain rules and regulation. So in that these two laws are much important. So I would like to give you some definition and meaning or explanation for this photochemistry laws. The first law I would like to take is Grothus-Draper law. This law states that all light radiations do not produce chemical reactions. So as far as we know that photochemistry is because of the light radiation. Just because of light radiation, we cannot get any chemical reactions. That is clearly given in the first sentence. This law states that not all the light radiation produce chemical reaction. Some increase the kinetic energy of the molecules while some are re-emitted. Okay. So some may increase the kinetic energy of the molecule and some may be re-emitted. Okay, then what kind of light radiation or what type of light radiation may increase the may bring about a photochemical change? Only that light which is absorbed by a system can bring about a photochemical change. This is very important law of photochemistry. So only that light which is absorbed by a system can bring about a photochemical change. Clear? This is the law of Groth-Draper law. And next, I would like to give you what is Stark-Einstein law. So this law states that each molecule of absorbing substance absorbs one photon or quantum of the radiation in the primary process. So this Stark-Einstein law clearly says that for each photon of light absorbed by a chemical system, only one molecule is activated for a photochemical reaction. Okay, I would like to revise the point of for each photon of light absorbed by a chemical system, only one molecule is activated for a photochemical reaction. Next, I would like to give you some of the points of de-excitation of photochemistry. What will happen? So before explaining that, I would like to give you some of the points of photochemistry. So how a photochemical reaction happens? A molecule is irradiated. So the molecule by irradiation, by getting the radiation, is excited to the higher energy level. And from that excited energy level, the molecule cannot stay in the excited energy level. It will use the absorbed energy, or by using the energy it should lose the extra energy. In some way it should use the energy or it should lose the energy. Okay, so that one of the way is the photochemical reaction. So by using the photochemical reaction, by using the extra energy absorbed, the molecule may involve in a photochemical reaction. Okay, by what are all the ways the molecule can do the by involve in the photochemical reaction. So let us see this topic now, that is de-excitation or stabilization of electronically excited state. By 5 different methodologies or methods, the molecule can come again to the ground state. So initially the molecule will be in the ground state, and the ground state molecule which is present in the ground state will be stable. If the molecule is present in the excited state, means it is energized. Even though it is energized, it is unstable or less stable. Okay, so by coming again to the ground state, they will become stable. So what are all the ways? So let us see the first point. By reverting into the ground state, just reverting, coming again to the ground state. By this methodology also, the molecule may involve in a photochemical reaction or just coming again to the ground state. By making bonds with the other ground state molecule. This is the second method, the molecules involving with and the molecule which are making use of the extra energy to come again to the stabilized form. That is, by making bonds with the other ground state molecule, the molecule which is present in the excited state may use the extra energy. And the third methodology is by decomposition. The absorbed extra energy can be used by the decomposition to come again to the ground state. Next, the molecule by involving in isomerization of the reactions to come again to the ground state. Next, the molecule may involve in quenching. We will see what is quenching in the next presentations. By involving in the quenching, the molecule may use the extra energy to come again to the ground state. So these are all the topics that we have discussed in the photochemistry presentation. So photochemistry and the comparison between thermal reaction and photochemical reactions, and photochemistry laws, that is Grothus-Draper law and Stark-Einstein law, and the different methods of the de-excitation or stabilization of the molecule. Thank you.